Hi, my name's Greg Dohrman, and I'm a Senior Solution Architect with IMAGINiT Technologies. I'm a part of the IMAGINiT Technical Services Organization, and I work with our customers to define and implement larger scale technology initiatives. Our goal here today is to provide insight into what it takes to develop a digital transformation technology strategy. First, a definition. Digital transformation is broadly defined as adoption of technology to transform services or business. And though there's a lot of recent media buzz around DT, or digital transformation, we have seen leading IT departments differentiate transform versus sustain projects for over a decade. And the key differentiator being, with transform projects, the process change is implicit. The target is to change the existing process through use of technology. So we've seen digital transformation initiatives in the form of digital twin initiatives, remote workforce support, sales automation initiatives, and field collaboration. In our session today, we're going to talk about the IMAGINiT approach for defining a technology strategy. We're going to cover defining objectives, functional requirements definition, high-level solution design, and execution planning. So much of the information we're going to be sharing today is derived from the IMAGINiT Take Aim implementation methodology. This methodology covers a project from definition phase to project rollout, and the information we're sharing today is based on this. So we're going to start by talking about objectives and requirements. Defining project objectives is key to success with any type of digital transformation, and these technology initiatives require clear objectives. Something like implementing digital twin may be too vague. Ideally, the objectives define specific outcomes. A couple on this list that I really like is an attainable goal, like respond to bid requests within 5 days, reduce engineering cycle by 20%. Those are attainable goals, and I think those are great objectives to lead a technology initiative. Once we understand the objectives, we can then determine how do we want to approach the project. Applying our Take Aim methodology, we often will look at it from a different perspectives. First, from the perspective of the business, what are the business functions that the technology initiative has to support? Second, from an IT standpoint, what IT infrastructure is it going to take to support the solution? And then finally, what's it going to take to deploy the solution out to end users? So we find by breaking this project execution strategy into 3 tracks, it helps us align better with our customers, keep the projects on track, and not lose sight of critical elements. So today we're focusing on definition, and within that process map, we'll look a little deeper at the definition components. First, we're talking about functional requirements, then use case definition, workflow definition, solution architecture, infrastructure architecture, and project execution strategy. This process starts with functional requirements gathering. During functional requirements gathering, we work to understand the current environment within the scope of the objectives. We map out key workflows, and we define how current systems interact with users within those workflows. We also document bottlenecks and gaps in the current processes and systems. Within this, our objective is to create a requirements matrix that specifies all project requirements necessary to meet the objectives. Once we have broad requirements defined, we then focus on use cases and work streams. Use cases identify inputs and outputs and workflow of key requirements. They are very concise in nature, and they are, an example would be the check-in and check-out process, for example. Once we have use cases defined, we can then link those together into work streams. Work streams are a higher level view that link one or more related use cases to a broader view. For example, change management. Change management encompasses the use case of check-in and check-out functionality and many others, such as requests for change, change notices, and other functions within the change process. Once we've defined the requirements, the use cases, and the work streams, we can then start to look at the solution architecture. The workstream view allows us to also to focus on the continuity of information flow throughout the system. Once we've documented the project requirements and understand the use cases and work streams required to support the solution, we then start solution architecture. I like to start solution architecture with a look at what's worked on past projects well. For example, if we're working on a collaboration project or a dashboard project, I want to look at past projects and common principles that made those successful. And these three here are ones that often apply to many projects we do. Within these projects, what we find is if our projects are promoting continuity of information flow, collaboration, and process control, these projects have a high probability of success. Each of these different pillars support each other and help each other function. So for example, if the work stream is engineering service provider collaboration, we want to provide continuity of information flow so that engineering service provider can submit engineering documents to our organization using our templates. So they're indexed into our system properly and we can search on those files. We also want to provide process control so that as our engineering service providers check those files into our system, they can't review or approve those outside of their own areas of responsibility. And by the nature of what we're doing, by allowing our organization to work with our engineering service providers productively, we are facilitating collaboration. So having some core principles like these to help drive the solution definition is very helpful. Beyond that, we start to look at what are the key digital assets that are going to be leveraged throughout the solution. So some examples of digital assets that a digital transformation project might entail could be project specification sheets, PNIDs, assembly models, bill of materials, electrical drawings, building materials, fabrication models, CAM files, change documents. And remember this, it's not always documents. Sometimes it's a form of information or a critical spreadsheet that gets filled out. That's all part of the digital assets that may make up the key workflow you're looking to transform. It's also important to look at key metadata that will be leveraged. Often these solutions bridge multiple systems, and it's going to be important to understand what are the key metadata categories that we need to capture and what are the fields within those categories, so that when we're working between business systems and engineering systems, that we have continuity of information flow and data can originate in one place and then be propagated to other systems without re-entry. Once we understand the digital assets, the metadata that we want to capture, we can then start mapping technology to the process and come up with what we call a mapped workstream view. So here we're showing technology that's being used within the workflow. So this is a very high level view, and it's just showing which technology is being used where within the process flow diagram in order to support the digital stream of information the company hopes to capture. Ultimately, that can then be refined into a system architecture that describes the targeted solution. This system architecture should address project objectives, show the supporting workflow requirements, and should apply technology in alignment with industry best practices. A system architecture should also define integration points. And beyond just a simple system map, the system architecture may require mock-ups or proof of concepts to validate key workflows before the project progresses further. After we have a system architecture, we can then look at the IT infrastructure necessary to support it. So this is an example of an IT infrastructure to support a data management project in the context of a digital transformation. But it's very important for the communication of the plan and supporting the rollout to describe not only what are the pieces of the solution, but also what's the hardware and infrastructure necessary to support the solution. Once the architecture is defined, we're ready to start planning the execution. Many projects that we work with take a phased approach. Many of them are too large to be handled in just a single phase, so we have to break them into phase, but each project phase should define the components necessary to provide the target solution. So here's an example of a target solution and the components that make it up. In this example, if we are looking at, for example, a target solution of engineering service provider collaboration, we would start with process definition. What are the workflows that those engineering service providers are going to specifically interact with within our engineering team? Then we would focus on solution development and software configuration. How are we going to provide a solution? Which software components and how will they be configured to meet the needs of the users? We would then want to develop standard operating procedures. not only are standard operating procedures critical for understanding how to use the system, but there's also elements like templates that facilitate continuity of information flow, so that engineering service provider work can be done productively and integrated into our own work without additional data entry. We would want to do validation testing. We can't put a solution like this in place without fully testing it, so validation testing is a critical element. Training is a critical element. So many projects fall short when the users don't fully understand how to leverage the solution. And then rollout support. How do we hold the hands of the users as they're ramping up and learning how to use the system to support an improved process flow? And all throughout the project execution, effective project management is key to driving results. So next, we'll just take a little deeper look into a few of these key elements that make up the execution plan. We talked about process mapping at an overall project level, but when we get into these individual phases, it may be necessary to put additional granular detail into the phases. Like I gave the example of engineering service provider collaboration, we may have specified in the overall project plan that we need to support it and some high-level workflows, but once we get to this point of this project, we're going to need to fully define the steps that are required, who's doing what, and specifically which systems and which functions are used within those steps. Within the standard operating procedure development, as we mentioned, there's not only just how do you do it, what are the steps, but there's also modeling conventions, templates that might become important, metadata rules for what fields have to be populated, what don't, data controls, and so forth. Another important element of an execution plan that's often overlooked is the validation testing. I never assume that a project's going to work as it's designed. I always want to prove that through validation testing, and that requires developing a test plan, doing some functional unit testing, which is basically people who are close to the project, executing the tests, and then once successful, involving stakeholders, end users who are going to participate in the workflows, and also to test the system and prove that it supports the desired workflows. Training content is also a huge element of successful implementation. Depending on the scope of your transformation, it may require classroom training or online content be developed to support the software use within those steps. And then finally, execution of the training, making sure that we have a plan to roll out the technology in a structured way, whether that's through classroom courses or self-paced learning. Either way, training is an important element of success. It's also important to note that a large technology transformation that has multiple phases may have a lot of overlapping parts, and it may be necessary to define some global components to your project. For example, a master data plan would illustrate which fields originate where, which systems own which data, and would provide additional detail on the metadata mapping. A master security plan would allow us to define universal roles, so different systems involved, like the business systems, the PLM systems, the data management systems, the CAD systems, all have consistent roles between the users that are interacting with the systems. So after the last couple days at the Elevate event, we've learned a lot about how technology can help us improve our organization, but big change requires planning. In our session here today, we've talked about the key elements for mapping out a digital transformation plan. That includes defining objectives, defining functional requirements, coming up with a high-level solution design, and execution planning. Strategic planning for targeted solutions can be difficult, and IMAGINiT can help make that easy. If you would like our assistance in helping you map out a technology strategy, please contact your IMAGINiT sales representative today. We will help provide a guided path to your goals and objectives and help you get technology supporting your business in the way you desire. With that, I say thank you for joining us at the Elevate event, and we look forward to working with you in the future.